Okay, so last time we did the configuration for HANA system replication, that is database DB replication. Okay, now let me first start the only challenge what in the last week's configuration was that okay, whenever there will be a disaster, or you can say wherever there will be an issue with the system, the failover has to be done manually. The switch, the takeover, that's a takeover has to be done manually. It was not automated, but in real time it cannot be like that, because see, you cannot depend on the system when it is going to fail. It can fail anytime. It can fail at like 3 o'clock in the morning. It can fail like at 2 o'clock in the afternoon when it's a very rush hour. So you cannot predict when the system is going to fail. So it can fail anytime, and at that time it is not possible for you to go there and do all the just okay. So it is not possible to go and do the switch over or take over manually. So for that, regarding the same, we have to automate the process. Automate the process is like that. Whenever there is a failure, the system should the system should manage the failover itself. So is my point clear?
Muzaffar?
Yes.
Yeah, hi. Before we move on to the next HA availability configuration and so on, see, last time we configured the system replication, right?
Yes.
Yeah, the only doubt I had with respect to that is using HANA Studio, or probably using the client commands, HTTP CLI commands at the OS level, we can only check that replication is active or not active.
Okay.
Correct. But my question here is, how do I ensure that the logs that are being generated on the primary are being shipped correctly to secondary? Okay. And another
Yes.
thing is, if there is any network latency in between, how do I check if it has stopped, or what is the log what are the number of logs that are unshipped or something like that?
For the same, I had mentioned it. I think you might have missed it. See, there's this command for that. If you see over here, watch HDB settings, system replication. It's a Python script. Okay, and this script we have executed last time in watch, under watch, to monitor the replication. Okay, so let me log in with SC. First, let me start the databases. SC by class, Okay, so let this start, then I'll answer your question. Okay, another thing, I like your way of asking question, because it's like someone is paying attention. Someone is like interested in the course. Okay, very good. Okay, next, let me start the secondary also. And also I will show you that last time when we did for the resetting the password of the system user, it was giving errors. So I will show you that today also. And plus I also noted down your other two queries of BW4 HANA sizing, and that creating a tenant table space and restoring the backup on it. So not
Yeah.
maybe today, maybe like today we'll be taking this topic of HA clustering, and it's a very lengthy topic. So
Sure,
today and
sure.
tomorrow also will taking this one.
Sure, sure, sure.
HANA cockpit. So that also is a lengthy topic. Maybe next week I think we'll conduct one additional session, and we'll
Okay.
like address your query in that.
Sure, sure, sure.
Yes.
The query I had with respect to tenant database was like how to create a tenant database as
Yes,
a
I got your
replica
point.
of the current tenant database.
Okay, so no, you cannot do that. You cannot create a tenant database as a replica. You have to create a new database, and you have to back up the source system and restore it on it. You can only create a table. You can only create a table as a replica of another table.
Okay.
Okay. There is a command for that. You can create a table, create table, the name of the table columns, and instead of giving the entries for the record, you can run a select query. Create table this and this, select star from this table. So it will create a new table with the records from another table. That is possible only in case of tables, not in case of database. You cannot create a database with a replica of existing database. You have to create a new database and then back up the source system and restore it on your target system.
Okay. Okay. Fine.
Okay, so both the database have been started. Let me check the replication status first. Okay, so this is my primary server. This is the node 1. This is my primary Mumbai site. Okay, this is my secondary system. And you can see this is the sync side. This is in sync status. Now, how to check if the replication is going on? You need to check and all of it. So you can run this query over here. Sorry, not the query. You can run this command here. Watch HDB setting. You have to run it on the primary system. If you run it on the secondary system, it will not give the full complete information. If you see, this system is either not running or not primary system replication side. So you have to run this command on the primary side. So here you can see over here, you can see all the information related to your replication. These are the databases which are being replicated. It is not actually database, this is the service name. These are the service names which are being replicated. So one is your system DB, and this is your services for your tenant DB. One is the access engine, and this is the index server. Okay, this is the host, your host. This is the port, volume ID. This is the site name of your primary or source system, and this is the site name of your secondary or target system. This is the secondary. So I think from this column, these are all the secondary information, secondary system information. Secondary system host, secondary port, secondary ID, and here you can see the replication status. The replication is active. Can you see the replication is active? And in case yes.
Yeah, but here it does not show like if there is a if there are missed logs or something. I am interested in the query or probably any command that will show me if there is a lag in log shipping or something like that.
Let me show you like this. So let me first stop this system. I'm stopping the secondary system. Now this will get giving issue with the connection timeout. So here you can see this is giving connection timeout, that it is not able to communicate with the secondary system. Actually, the database is the initial database. It doesn't have any load, so it goes up very quickly. So if I let it completely shut down, when I will start the secondary database, you will see over here that here it will show you, first it will show you initializing. The status will show initializing, that will show you syncing. And same here in this line, here you can see the number, the percentage of data which has been replicated and how much is remaining. Okay. Let me stop this. Let me break the replication. Then I will stop the database. So all has been timed out. Communication channel place, communication channel place. Now let me stop it. Let me unregister. And I'm registering the secondary site. Actually quickly changing the states of the database, it gives issues like this. Because I was just starting it, stopping it, such so quickly without any interval in between. Okay, if you see you're preparing persistence, just see preparing persistence. This is one log. Okay, it directly went into active because it was already synced. Initializing. Okay, preparing persistence. I directly went to active because I'm not able to unregister it. If I unregister it and register again, it might start the replication from scratch. You will start from scratch. From here only, you will see the status that it has started replicating. It has completed so much percentage. It will start with 1%, 2%, 10, 15, 20, and that will show that is the how many, what is the size of the total size of the database which is replicating and how much is remaining. So this is one way you can get it. And next, okay, you're talking about the logs, and also let me for this, I will let you check and let you know about that.
Sure, sure. You understand, right? In
Yes, I
Oracle,
got your point.
we check the log sequence number or something. So we check like if this log sequence number is shipped to the secondary site, or probably the sequence numbers from 101 to 108 are still not shipped to secondary or something like that.
Okay.
So how do we do that in the HANA case? That is what I'm interested in.
Okay, we'll check and let you know about that.
Sure.
Okay, and regarding the changing of the password, okay, I think we'll take the topic of changing the password in the additional session that we'll be taking, because today's topic is how very lengthy. So I don't want to waste this time. So I think you have to, I have noted down your query and we'll take it in the additional class.
Okay, no problem.
Okay. So now we have started the database. My node 1 is in the primary state and the node 2 is in the secondary state. Now, in case of any failure, I will have to here in the current situation, I will have to do a manual failover. Okay, it will not be automated, but manual failover is not practical. You cannot do it practically anytime, because the situation can arise anytime. So it's not like you can keep one person like ready, like whenever it fails you have to do and do this. So because of human error and because of this availability issue and all, it will take a time. There will be a difference. There will be a longer downtime in case if you wait for manual takeover. So now for this, what we will do, what we can do is that we can set up a cluster. We can set up a high availability cluster. Cluster is nothing but it's a separate application or software which manages your services. It first thing which it does is that it monitors your services, whether the services are running or not. And if the services fails, then it will take corrective actions. And the corrective action with this, I mean that you will have to define, you have to tell what corrective action needs to be taken. For example, if this services fails on node 1, then if you have defined like first try to restart the service on the failed node itself, then the cluster will first restart the service on the failed node itself. And again, if it doesn't comes up, then the next step, it will try to move the service from the failed node to the good node. Okay, so now about this failover, let me first you need to understand what are the cluster components or cluster things which comes into picture. Consider requirement of the okay, for HO class, so what are the cluster components that come into play? So these are the some of the terms that we'll be understanding in the next couple of slides. Okay, the first thing is a virtual IP. Now, what is a virtual IP? Then again, what is a load balancer? Then comes the Stoneit. Shoot the other node in the head. This is a kind of a solution. This is a kind of mechanism method that is deployed to monitor the resources and to take corrective actions in case of a failure. And the fourth one is the Stoneit based device. So let me now show you an example of about a cluster, how a cluster works. Okay, so now in our case, what we have over here is we have two nodes. We have two nodes of a HANA database. We have two HANA database nodes. One is a node 1 and the second node 2. HDB PRD01, HDB PRD02. These are the NICs of each of these servers or VMs or whatever host is, and these are the IP address of each of these nodes. Okay, so the node 1 has IP address 10.0.1.5 and the node 2 has IP address 10.0.1.6, and these are the physical IP addresses of these nodes. Okay, these are the physical IP address. Second, we have configured HSR, HANA system replication on both of these nodes, and data is being replicated from the primary to secondary. Okay, so this is the execution scenario. Now what we have over here, we have these servers are connected to the switch. These servers are connected to a switch. Now we have the application server. Now these are the application servers. Okay, for example, as for HANA PRD01, PRD02, PRD03, and 4. These are the four application servers, and they are coming to the switch, and they are connecting to your database servers for the backend database, for getting the data from the database. Now what happened? Now the question here arises, okay, now there are four application servers. Now how will the four application servers come to know that on which node the database is running, or on which node the database is in primary state? Okay, because out of these two database, only on one system it will be in the primary state, and on the second system it will be running, it will be as a standby mode or just as a read only mode. So you cannot, the application servers cannot access data from the secondary system. So they have to come to the primary system. Now, how are they going to identify the primary system? So to tackle this scenario, what is done over here? A virtual IP is assigned to the working node or to the active node. A virtual IP means this is not a physical IP. This IP is assigned on top of your physical IP. It is just an additional IP, and if you say as it for virtual IP, or also called as a floating IP. Virtual IP or floating IP. Floating IP means it moves from one node to another. It is not stuck with any node. Like the physical IP address, it is not binded to any NIC card, any network card. Okay, it is just a floating IP address. On it, and anytime it can be on one node, and the other time it can switch to any other node. So now what happens in case of this primary nodes go down, the primary database or this hardware goes down. Okay, so what happens? This the virtual IP, it moves from the failed node to the second node, the standby node. So this is how a virtual IP works. So this is one term that you will be understanding over here, how the application server identifies to which server to connect to. So they identify the working or active system by the virtual IP. Actually, it's a very simple concept. At the time of installing the this application servers, you don't give the physical IP of the database. You only give the virtual IP of the database. Okay, and normally in the application servers, you'll pass an entry in the etc host file with the virtual host name. Okay, for example, these are the two databases. I think last time we did an entry in the system information. Here, if you see the first SK information, see here it is the host name static. The static host name here it is. These are the host name, and this is a static IP address. Now here we have the virtual host name. This is the virtual host name. So here this is HDB PRD 01 and 02, and the virtual host name is HDB PRD, and the virtual IP address is 10.2.1.11. So this is the case. And also we did an entry in the host file. In the host file, along with the primary and the secondary system, we have also entered the host name and IP address for the virtual. So here it is. So similarly, each of these application servers, there will be an entry for the virtual host name of the database. And at the time of installing the application server in SWPM, and the screen comes when it asks you to enter your database details. So there you will give, instead of giving the physical host name and physical IP address of the database system, you will be entering the virtual host name and virtual IP address of the database system. So that, sorry, virtual host name, there's an ask for IP address. So you can give the virtual host name, and to internally it will resolve the virtual host name to the virtual IP address. And that is how it will work. So every time the application server will only go looking for the virtual IP address. And in case the virtual IP address moves from the active node from the failed node to the second node, the system will then, instead of connecting to the first node, now the switch will redirect all the connection to the secondary node where the virtual IP address is active. Is this point clear? Okay, so now this point is clear. Now, so this looks very simple. Now that the thing comes, who will move the virtual IP from the active node or from the failed node to the secondary node, and also who will start the service on the secondary node. So in this scenario, the cluster comes into this cluster application, the cluster program or the cluster software, it comes into the picture. So we will implement we will implement cluster on both of these nodes, and we'll configure the cluster. So the cluster will be configured in such a way that in case of one of the nodes failing, if one of the nodes fail down, for example, the primary database node fails down, the cluster, what will the cluster do? The cluster will start the service on the secondary node, and it will move the virtual IP from the primary to the secondary node, and it will the second node. So once it is done, the application server once again will be able to connect to the active node, which was earlier the secondary node. Okay, is this clear?
Yeah.
Okay, so now comes here. So here you have understood the concept of virtual IP. What is virtual IP used for, and how it is used, and what is the function of a virtual IP. Now coming to this point, now there is a challenge over here. What challenge is it over here? The challenge here is that, see, now here we have identified that the production system, this first node, the node 1 HDB PRD01 has gone down, or it has failed. Okay, but how will we ascertain, how will we confirm whether the node has actually gone down, or only there is a disruption only in the network service? Okay, in case maybe the network cable has been disconnected, so the system is still running, database is still running on the primary system, everything is still running, all the things are working, only is that it is not the application servers are not able to connect to the primary node because of network failure, network disconnection, but the first node is still running. So in this case, because see, any application, any program, how will they find or how will they test if that particular service or particular node is up or not? See, the simple thing is that they will ping that system, they will telnet or they will check the port on that system whether it is running or not. But if the network is only down, then how will they find whether the system is actually running or it is just not accessible through a network? Okay, and in this case, if there is a mistake, okay, if the system is still running, if the database is still running on the primary node, okay, and the cluster makes a failed decision, a cluster makes a wrong decision and it starts the services on the secondary node. So now you will have two active systems in your landscape, in your environment. Okay, and this will lead to issues, and this might also lead to data corruptions also. Okay, because some transactions are already been running on the node 1 and now it was switched to node 2. Now it will, so there might be a loss of some data also, and there might be some uh, inconsistency in the data. Okay, so to tackle this scenario, this is also called as the split brain scenario, split brain, where the system, where it is not the application, the cluster is not able to confirm whether the first node is actually down or not. So how to confirm or how to tackle this situation? To tackle this situation, what they have done, see, now the thing is that if the network is only gone down, then how will you find whether the node is up or not? So in this scenario, what the solution they have? The solution they have is the stone it, shoot the other node in the head. So what is this solution, or what is this mechanism? What it does? What it does is that it identifies, it finds whether the primary node is up or not, or if it finds that the node is up but sub services are not running. So what it will do? It will shoot the other node in the head. It means it will forcefully crash the first system. It will forcefully crash the first system, and then it will bring up the services on the secondary node. Then only it will bring up the services on the secondary node. So that in case in the future, in case if the, for example, if there's a network disruption on the node 1, and after some time if the network gets disconnected or it again gets online, so it shouldn't lead to any kind of data inconsistencies or any issues in the connection. Okay, so yeah, so this is called as the Stoneit mechanism. Now, how to implement or how to deploy this Stoneit mechanism? So to this, what is done? Three, you can connect the shared disk. Okay, to apply or to deploy this Stoneit mechanism, a shared disk. It can be one also, it can be three also, but it has to be in odd numbers. Okay, the shared disk, these disks are also called as voting disk. This is also called as quorum disk, and all there are many names for it. So these are also called as a voting disk or quorum. So it has to be deployed in odd numbers. You can either deploy one or three. In a critical environment for critical systems, three storage disks are recommended. It is recommended to have three shared disks, and this doesn't need any kind of space and all. This doesn't have to be like a large in volume. The minimum requirement to have a quorum disk is like, can even have a disk of 100 MB. Okay, but in normal environment is not easy. It's not so simple to have a disk of 100 MB. So normally they go with a disk of 1 GB, 2 GB, and in case of cluster, in case of a cloud and all, they go with a minimum disk size of 4 GB. So one disk of 4 GB. So you can go with either one disk of 4 GB or three disk of 4 GB each. So this disk will be at a time connected to both the nodes, the primary and the secondary, and both the nodes will be writing data. What data they will be writing? Their information, how, where with this system, whether it is connected or not, whether it is working or not. All this kind of information will be written on the shared disk. And in case of one of the nodes fails, the cluster will take the information from this shared disk, from this disk, and then it will calculate whether which nodes, whether to move the services from the primary or failed node to the secondary or not. Is this clear?
Muzaffar, can you repeat the last statement, what you said just now?
Okay, so now see, now here in this case, for example, we have two systems, node 1 and node 2. Now database, the node 1 is active. Node 1 is active and your database is running on the node 1. Now that node fails. Okay, now that node failed. But how will the cluster service? How will the cluster service identify whether the node 1 has actually failed, whether there is a hardware failure, whether the node 1 has completely crashed, it is not workable, it is not working, or whether there is only a disruption in the network service? If there's a maybe in the disruption in the network connectivity, or maybe an issue with the network card, or maybe an issue with the network driver. So even only if the network card is not working, the database and all the services, those are still active on the sub primary node, on the primary or active node. Only if only the connectivity is disconnected, and if the cluster brings up the database on the secondary node, then there will be there can be a data inconsistency between both the nodes. Okay, there will be the data between both the nodes, they will differ from each other, and this will lead to an issue in the future. There might be like a data inconsistencies. So to handle this situation, to tackle this situation, what is done, uh, a shared disk a shared disk is mapped or connected to both the systems at a time. Okay, a shared disk is connected to both the systems at a time, and both the systems, they write their online availability information on this disk. Okay, so even in case if a network is disconnected, even in case if a network, there is a disconnection in the network, but the disk is still connected to both the nodes, and the data is all and the data is and both the nodes are writing their information on this disk, and through this information on the disk, the cluster will come to know whether the first node, active node, is working, is up or not, and what to do. So in case if we find that, okay, in the first node only the network is down, and if the network is disconnected, the first node is not accessible, how will the cluster give it a command to shut it down, so that it can start the service on the secondary node? So through the same shared disk, it will write the command on the shared disk, and the first node which is not connected on the network, which has some network disconnection, it will read the command from the disk, and what it will do, it will crash the primary system. It will crash the primary system so that the cluster can bring up the services on the secondary system. Is that clear?
Yeah, but this shared disk is only used for writing purpose, or what does it contain actually?
Yes, I told you that there is a minimum requirement. There's a minimum required. It only needs to write some voting information. Which system is coming up? What is the health of this situation? Oh, so normally what happens? Both the systems write their health information on this list, and it's a very minimum requirement. If you go by the book, it is only 1 MB is required for writing this information. Only 1 MB. Okay, but you cannot create a disk of 1 MB. Where is this? Storage based data. How does cluster know if it is failed to fail over the disk size? I read it somewhere.
Muzaffar,
Yes,
is this a physical disk?
yes, it's a physical disk.
So in the physical disk, can we create three partition and we can name it three, or we have to have separate three disks?
No, see, in that case, see, you will have a single point of failure. If you have a same disk and if you create three partitions on it, and if the disk goes down, then how will you do it? So that is called as a single point of failure. Okay, so in case if that disk goes down, if the controller of that disk goes down, if something with that disk happens, so all the three partitions will be affected, no?
Okay, okay. So there is a possibility of failing of this drive also.
Yes, yes. See, this
Where
is
it
a very
resides.
normal concept in a data center architecture, like
Okay.
creating or setting up a data center. In data center, it is that nothing should be a single point of failure. Nothing should be set as in that one, if one thing fails, then the whole services goes down. So this is not designed like this. Data centers are not designed in such a way. Where did I write it?
And okay, so
Yes, yes.
these 3 disks, where we are installing these 3 disks, is it installed in
We will
any
come
of?
to that. We'll come to the
Okay,
practical
okay,
part. Now I'm just telling you the
okay, okay.
yes. The SBD device requires at least one additional virtual VM that acts as an internal small computer. Because I don't remember where I read. Okay, so the minimum requirement is 1 MB, but you cannot have a disk with 1 MB. So normally you can have a minimum disk of 100 MB in case if you have a, like a virtual scenario. So you can create a 100 MB disk, iSCSI, which is called as the iSCSI disk of 100 MB, and attach it to both the systems. Or you can also, but in case nowadays the normal standard is like 1 GB. Either go with a 1 GB or go with a 2 GB. And in case of cloud system, in cloud, in Azure, you don't have any disk which is with a lesser volume than the 4 GB. So that is the reason in case of Azure cloud, you have to add a disk with 4 GB only. You cannot go lesser than that. But in case of AWS, you can create a less disk also, like say for 1 GB also. So there in case of AWS, you can attach a 1 GB disk also to both the nodes. Okay, so that is it. So this is, I think you have understood the architecture of it, of this, what is a cluster, what is a failover, how it happens, the failover and all. And what is this, what is the concept or what is the definition of this SBD, storage-based device or storage-based death. Okay. Now, the second thing which the second component which I was explaining you was the load balancer. The first one was the virtual or the floating IP. Virtual floating IP. Second comes your okay. Then second comes the virtual. Now, in case of a cloud, in case of cloud environment, cloud platform, you don't. There is no option for having a virtual IP. Okay, you cannot, because in the cloud the VMs are created and the NIC cards are they are hardly bind to the VM, so you cannot add a virtual IP or floating IP to any of the NICs. It is not as flexible as it can be in your on-premise setup. So for this reason, what solution Azure or what other, even in other cases they have provided is that you have to configure a load balancer. You cannot directly assign a virtual IP on your systems, and they cannot move freely from one node to another. So to have this to get this solution, we have to deploy a load balancer, and after deploying the load balancer, you have to give the virtual IP for the on that load balancer. You have to configure the virtual IP on the load balancer, and you have to add both your nodes. You have to add both your nodes to the load balancer. The load balancer will then check the health of both the nodes. Okay, which system is running and not, and what the virtual IP on which system it should be the virtual IP is assigned or not. So with the combination with the cluster, the load balancer in combination in partnership with the cluster, it will decide on which node the virtual IP is running, and after failover on which node it has came up. Okay, so is that clear with the load balancer? This is actually a load balancer. In this example, this is a load balancer. Okay, this is the load balancer. This is a router, I think something. This is a load balancer. So it is connected in the background. It is connected to both the nodes, the node 1 and the node 2. And this is configured into your HANA system application. Okay. Is that clear?
Load balancer is a physical device, correct?
No, it's not a physical device. It depends upon it. So normally load balancer is started with a physical device, but now slowly everything has moved from physical to virtual also. So now in our case, in cloud environment, it will be a virtual service. You can call it as a service.
Okay, okay.
Load balancer. Okay, so now I think we have completed the theoretical part of this, and now we'll move to the practical part of it. Okay, so here it is. So I showed you what is the virtual of floating IP, where is the load balancer used, what is Stoneit, shoot the other node in the head, and what is Stoneit based device, SBD. So the disk that we're using in this case, the shared disk, they're also called as SBD disk, SBD disk, storage based device disk. So this is a storage based device disk. Now let us start with the practicals. Okay, our VMs are running. Our VMs are running. Now, first thing is that we'll start by first we'll create a load balancer, and then we'll move ahead with the configuring the cluster and everything. So here is it. So if you scroll down over here, this is the part where you can create the load balancer and the shared disk. Additional steps for HA. So here you can create the load balancer. This is the load balancer. So these are the steps for creating the load balancer from the portal side, and these are the commands for creating the load balancer from your command line. Then comes your create and attach an Azure disk to HANA. Okay, so here is the steps. These are commands for creating the shared disk. Okay, so now I have not given the portal over steps over here. The reason is that you can only create the disk from the portal, and you can only assign the disk to one node at a time. From the portal, there is a restriction that you cannot assign one disk to multiple nodes. You cannot assign one disk to multiple nodes. So that is the reason for this step, the step number 3. For assigning the same disk to the secondary node, you have to do it with the command line only. There is no other option. Okay, you can create the disk from a portal. You can attach the disk to one of the nodes from portal, but you cannot assign the disk to the secondary node from the portal. So for the third
Portal
step,
means Azure, correct?
yes, from Azure portal. See, these are all the
Okay.
steps which we are
Yeah,
doing from the
AZ,
Azure portal.
AZ. Yeah, okay.
Okay, so that is the reason. So this is the third step, has to be done only through command line only. So that is the reason, instead of showing the steps from a portal, I've just directly given the command for creating the disk and assigning it to both the nodes. Let's start with creating the load balancer. Okay, so here is our here is a portal. This is Azure portal. And now we are going for creating the load balancer. The first step, create load balancer. Where you can create the load balancer, networking, load balancers create. So where you will find networking, you can directly go under here, all services. Under all services, go down to networking. So this is the networking. And in the networking, you will find the load balancer. If you see over here, this is the load balancer. So here you can find networking, all services, networking, load balancer. Coming under load balancers, you can click on create. So now I'm going to create a load balancer. Okay, so this is the screen for creating a load balancer. Okay, now first thing you have to say, mention in which resource group you want to create the load balancer. So I'll be creating a resource under R B0200 HANA RG. This is the resource group, because this is the VM under which okay, so this is a VM. This is a resource group. This is a resource group under which our VM is running. So I will create the load balancer in the same resource group. So here I'm taking this resource group B0200 HANA RG. Okay, then name. What will be the name of the load balancer? To identify this service, we have to give it a name. So this is the name of the load balancer, B0200 HANA -LB. LB short for load balancer. Region will be the same, East US, no changes. School will also be standard, no changes. Okay, here you have to give type. Type here you have to give internal, because we'll be using it for internal purpose. We are not, this load balancer will not be exposed to the internet. It will not be exposed to the internet. It will not receive traffic from the internet. Okay, so it will be an internal load balancer. Internal load balancer. Then second, add a front end IP address. So this will be the IP address on which all the systems will be connecting to all the other application servers will be accessing this IP address. So we have to front end IP configuration. Just click on the next over here, next front end IP configuration. So click here and go to the next screen. Here I move to the next screen. Here I have to click on add front end IP configuration. What is here? Add front end IP address. So here it is, add front end IP configuration. It is not address, it is configuration. Add front end IP configuration. Add front end IP configuration. Okay, now first thing is the name of the configuration. So the name of the configuration will be B0200 HANA LBFE, load balancer front end. Then on which virtual network, in which virtual network you want to put this front end or put this load balancer. So I'll put into my same network B0200 HANA VNet. Subnet, under which subnet you want to put it, private or a public? So not public, I'll put it in my private subnet, private SNet. Then the assignment, how the IP will be, whether it will be dynamic or static. So it will be a static IP address. What is this IP address? This is IP address 10.2.1.11. So this is here. Now you can click on add. I click on add, and here you can see the configuration for the front end IP configuration. This is the front end IP configuration. Okay, so this is the IP on which the external systems will be connecting to. The IP on which the external systems will be connecting to 10.2.1.11. Now against this front end configuration, you have a back end. What is a back end? In the front end, all the system will only see 10.2.1.11. Okay, but in the background, which system has the virtual IP? So how will it be decided? So there you have to create a backend pool. In the backend pool, you have to add all the VMs. Okay, on which on the VMs on which you want to you will be a part of this cluster. Okay, which will be hosting the database, and these VMs and the cluster will decide on which VM the virtual IP is running or not. So next, I'll be creating a backend pool. So backend pool, add backend pool, add a backend pool. So here it is, add a backend pool. Add a backend pool. So first thing is that you have to give a name for this backend pool. So the name of this backend pool is this B0200 HANA LBB, load balancer backend. So this is the name of the backend pool. Now here you have to mention which VMs or which systems will be a part of this pool. Okay, so you have to give to the NIC address. It will be default NIC only, IP address B4. Here click on add. Now here you have to select which system will be a part of this. So here you can select the second and the third one. That is the HTTP-PRD01, HTTP-PRD2. These are the two nodes which will be a part of this pool. So add these nodes into this pool. Now you can see these two nodes have become a part of this backend pool. So front end, on the front end, you have configured the IP address 10.2.1.11. In the back end, you have configured the VMs or the nodes on which this IP address or the virtual IP address will move from on the nodes on which it will move from on which on the nodes it will move, it will be active. Okay, so here it is. Now after adding the VMs or nodes, just click on add. After add, now you can see that your this has been created. Your backend pool has been created. The same, it's a backend pool. The same, this is the same name, but here you can see the difference. This is the resource name. This is the name of your VM, the PRD01. This is PRD02, and this is the IP address of these VMs nodes, backend nodes. Okay, now we have configured the backend pool. Now we have to add a load balancing rule. You have to make a rule how or from which port to which port the system should connect and everything like this. So here after this, you will click on next and it will take you to the screen for creating the inbound rules. So here is the load balancer rule. This is the load balancer rule. Just click on new, add a load balancing rule, add a load balancing rule, add a load balancing rule. So click on the load balancing rule. You have to give a name for this rule. You can have multiple rules. Okay, it depends on like how what rules you are putting. For example, traffic coming on this IP address on port 80 should be redirected to this VM, this node in the backend. or traffic coming to the port 3201 on the this front end should be redirected to this node on the back end. So these are the rule, and there can be multiple rules. So for each rule, to identify each rule, you have to give a name to the rules. So the rule name which you are giving is this LBR, load balancer rule. Okay, so I'm giving a rule over here, load balancer rule. Or you might also give it something name numbering like LBR1, rule number 1, rule number 2, rule number 3, and so on like this. So this is your load balancer rule. Okay, front end IP address, which is your front end IP address. So my front end IP address will be my LBFE front end 10.2.1.11. This is my front end IP configuration. Then what is your backend pool? Which is your backend pool? So this is my backend pool, HANA LBBE. Okay, you can have multiple pools in the background. So you can have like from this front end, it should be redirected to this pool, from this front end to that pool. Okay. Then comes your HA port. So here you can select that it will be an HA ports, high availability ports. Okay, we'll take a like 10-minute break and then we'll reconnect again. Okay.
Okay.
Okay. So this is the name of the health probe. While creating a health, it's creating health probe. The first thing you need to mention the name of the health probe. So here I'm giving by the name of my group, there's a resource group, and LBHP, load balancer health probe protocol. The protocol will be TCP. TCP protocol port number. So this is the port number as per the documentation. Azure recommends this port number 625 and the instance number. Okay, 625 and the instance number. Since the instance number is 01, I am making it 62501. So the port number is 62501. Okay, floating IP. So here's an option for floating. Okay, not here. So I'm adding the health probe. Click on OK, and the health probe is added. In the last option over here, there's an option for floating IP. So you have to enable this floating IP. Enable the floating IP. Enable. And now click on add. So now you can see that you have added one load balancing rule over here. No need to create an inbound net rule. No need for this net rule. Okay. So here it is. So what we have done, we have created a load balancer. We have created a load balancer. We have created a front end IP configuration. We have created a back end tool. We have created a load balancing rule. And then we have created a probe, health probe. So this is how you create a load balancer. Next, outbound rules. No need for outbound rules. Just click on review plus create. Running final validation. Okay, validation pass. Now click on create. Now it will start creating the load balancer. So this is the way how we create a load balancer. Started creating the load balancer. Now, by the time the load balancer is being creating, let us go and create the shared disk and assign it to both the nodes. Okay, so here are my both of these nodes. This is the node number 1. This is node 1. If you go in the disk section, here you can see all the disk over here. Actually, I had already created and assigned. So let me just delete it and let me recreate it again. Okay, this is the option over here by which you can invoke a cloud shell. In this cloud shell, you can give the cloud commands for Azure. So if you see in the secondary node, so this is the disk. This is the common shared disk. If you see over here, B0200 HANA HDB PRD SDB SBD disk 1. This same disk is assigned to both the nodes. This same disk is assigned to both the nodes. Okay, you can directly go and click the create and attach a new disk from here. Sorry. So here, from here, you can create a new disk and attach it from here. Let me detach the existing disk and let me delete it and create it again. So this is how you can detach the disk. This is the secondary node. This is the disk which is attached to it. Refresh it. Here you can see that the disk has now disappeared from this list. The shared disk is not available on the second node. Okay, so now I've got the prompt. Let me detach it from the first node also. This is the first node, node 1. This is the shared disk. Let me detach it from here also. Okay, let me refresh the screen. Okay, so you can see that the shared disk has now disappeared from here. Now let me delete the disk. It will list all the disks which are there attached in this. So this is the disk over here. It has been unassigned to both the VMs, but it's still not deleted yet. So we have to delete it. We'll delete it from here. Yes. Okay. So now if I run again, so you can see this disk which was there earlier, this disk has now been deleted. This 4 GB disk, the size of this was 4 GB. Now this disk has been deleted from the list resources. So now I will go and I will create again the same disk, recreate it. This is the command to create the disk. This is it disk create, and then name, resource group, premium. It has to be a premium disk. Okay, size 4 GB, max shares 2. Okay, the disk has been created. Now if I check the number, the list of the disk, so here you can see this disk has been recreated again. Now I had to attach this disk to both the nodes, node 1 and node 2. So right now there is no disk attached to here, node 1 and again node 2. Okay, now first I will attach it to node 1. So this is the command to attach the disk to node 1. Okay, so let me check on the first node. Okay, so here we can see that this is now attached to the first node, node 1. Now let me attach it to the second node. Okay, so it has been attached to the second node also. We'll check it, refresh. So now you can see this the shared disk has been attached to both the nodes, node 1 and node 3. Okay, so what we have done, we have created a load balancer, and second we have created a shared disk and attached it to both the nodes. See, normal I said that you can have one disk also and you can have 3 disks also. In critical environment 3 disks are recommended, but since this is just a test environment, so I am only creating one disk. But you can do the same steps, you can follow the same steps to create additional 2 more disks and attach it to both the nodes, in case if you are doing the configuration for a production or critical environment. Okay, so this all is done. In the disk also. So I created the disk and attached it to both the nodes. So now here on this part, the cloud configuration part is complete with this. Now let us move to our HA configuration part. Here is it. So this is our HA configuration part. Now what is it? 2 node cluster. Scale up single box to single box. So you cannot do this configuration in a multi-node environment. Okay, you have to do it in a scale up environment only. Single box to single box. This is the Stonich method. The cluster must include a valid Stonich method. So we have attached the shared disk for this Stonich method for this SBD device, and while doing the configuration, we will configure it as a Stonich device. Done. DHCP assigned IP addresses. The use one DHCP assigned IP address on each. So this is not as per our setup. This is not applicable. Users and groups. Technical users and groups such as SID ADM are defined locally in the Linux system. So don't go with the centrally users, but you have to define all the users in on each of the nodes which are there in the cluster. Name resolution. The name resolution of the cluster nodes and the virtual IP address must be done locally on all the cluster nodes. So in our OS configuration, OS setup part, we have added all this IP address and host names and IP address of all the nodes and the virtual in our host file of both the nodes. Time synchronization between the cluster nodes using NTP. So in case if you are doing this configuration on an on-premise environment, on physical servers or on a virtual machine or VMware virtual machine, then make sure that you configure NTP on that. We are not configuring NTP in our environment because the cloud VMs, they are synchronized from their hypervisor. So no need for configuring the NTP. But in case if you have to configure, the steps are given over here. These are the steps to configure the NTP. Okay, and the only prerequisite is that internet should be available because they will be connecting to this outside server, pool.ntp.org. So internet should be enabled on this system to communicate with the external NTP servers. HA time synchronization done. Both SAP HANA instances have the same SAP SID and instance number. The same prerequisite which it was for system replication, a DB replication, same SID and same instance number. Cluster nodes placement, so this is also not applicable. automated registration of failed primary after takeover. It means now two nodes are running, node 1 and node 2. Node 1 is primary, node 2 is secondary. In case of a failure, node 1 goes down, the services are migrated to node 2. Node 2 becomes primary. Okay, now after some time, when the node 1, the issue, the error of the node 1 has been identified, it has been corrected, and now the system is up again. Okay, the node 1 has again started up. So in that case, so here what is said, the automated registration. So here by default it is off. We don't keep it automated registration on, because if the second node come up, it will again start to register with the cluster. So this is in the starting, actually at least in the starting period, at least for 2 or 3 months, keep it off, so that you identify if there's an issue or not. Because in case there is a movement, the cluster moves to the secondary node, and in during that time only, if the first node comes up, it starts registering itself, it might create some issues. So automated registration. For starting configuration, we recommend to switch off automated registration, that is automated underscore register is equal to false. Is default. By default, this is the setting. So for the first initial timing, maybe 2 or 3 months or 1 month, keep it as it is, don't change it. You need to manually register a failed primary. After, so if a system primary fails down, after it comes up, you have to manually register it. For optimal automation, we recommend automated register is equal to true. Okay. HANA instance startup at boot. Automated startup of HANA instances during system boot must be switched on. Okay, if you remember, during the time of installation, there is an option where it asks whether you want to restart enabled. So restart enabled means whenever the system restarts at the time of boot, at that boot time, it will start the HANA database also. So by default, it is not enabled, and we don't enable it. So that anytime if you reboot the system, the database should not come up manually. You should go and start the database manually. Oh, sorry, the database should not come up automatically. You have to go and bring up the database manually. So that is the default setting. So here it is saying that don't keep it, don't enable this setting. AWS account. All components of the cluster AWS service should reside in the same AWS account. The use of VPC router. So this is related to your AWS account. So this is not applicable in our scenario. Okay, so is it clear with all the prerequisites? Yes, everyone, it's clear with the prerequisites. Okay, so now let's move with the HA configuration. First, now here if you see there are two columns. First column is for node 1 and the second column is for node 2. Most of the settings you have to do on both the nodes. Wherever you can see pending on both the column, it means you have to do it on both the nodes. Where you see not applicable means in this configuration you have to do it only on one of the nodes. Okay, so you can see this configuration has to be done only on node 1. This configuration has to be done on node 2. So now let's move ahead. The first configuration of first setting is that you need to disable timestamps, TCP timestamps, because TCP timestamps will cause the health probes to fail for Azure VMs placed behind Azure load balancer. So because of this, you need to disable TCP timestamps. So first check in your system whether TCP timestamps is enabled or not. So if I check in my system, these are my two systems. Come to the root user. Yes, I'm running this command. So you can see one means that it is enabled. TCP timestamps is enabled. So we have to disable it. So disabling is 0. 0 value means disabling. So copy and paste it over here. It will disable the TCP timestamp. So the TCP timestamps have been disabled on both the nodes. Second, check if the shared disk is visible. LSDLK, check if the shared disk is visible on both the nodes. So if you see over here, if you go on the last line, you can see this 4 GB disk. So this is the shared disk. It is visible on the first node, and check it on the second node. It is also visible on the second node. You can see over here. So it is visible on both the nodes. create the SBD device. So now we have to configure this disk. You have configured this disk as an SBD device, Stonic based device. So what you will do, you have to run this command to configure it. Okay, if I run the dump on it, it will give an error. Okay, header on the disk not dumped. So first create the configuration. Second also will get the same error, not dumped. So create the configuration first. Okay. No need to run this command on both the nodes. It has to be run only on one of the node. Okay, since it is a shared disk, so no need of running it on both the nodes. So just run it on any one of the nodes. So here you can see after running the device, I can see over here. After running the device, I can see over here. Okay, so we have created the SBD device. Next comes to update the SBD configuration file. So there is a configuration file by the name etc sysconfig SBD. So in this file, you have to update the ID. You have to update the disk ID of this disk in that file. So first take a backup of that configuration file. Take a backup on both the nodes. Backup of this file on both the nodes. So here I'm taking a backup. Okay, then I have to find the ID. You have to find the disk ID of this shared disk. So by running this command, you can find the disk ID. So this is the disk ID. Can you see? This is the disk ID. Dev/disk by ID Kazi minus, and this is the number 3602. So this is the disk ID. Just paste it over here. Once you paste it, this command will get updated. Once I update this field, so you can see this command has updated. Yeah, this command has got updated. So after entering over here, now copy this command and it will update this file. If you see if you see the difference between both the files, so there is no difference between the original and the backup file. Now I'm making the changes in the file. I'm making the changes in this file. So I made the changes. Now if I run the diff command, so you can see there is a difference in this line. In the previous file, this was this line, and the new file, this is the line. So this is what we have done. We have added the ID of the SBD file into this SBD disk and this file. Now if you check the same on the second node also, difference. So there is no difference. So first you need to update the file. I updated the file, and if you need, then you need to check the difference. Then you can see the difference. So here I have updated the SBD config file. Create a software watchdog. So this is how you create a software watchdog. Just echo softdog etc module softdog.com and node. So run it on both the nodes. So this has been loaded. This module has been loaded software, and this is the details of it. This has been loaded. Software watchdog done. Okay, now start with the cluster configuration. Cluster configure HA cluster. So by default, it is recommended. It is advisable to run and update. First, update your whole system. It is recommended to update your whole system before configuring a cluster. But for this, you will need a subscription from SUSE. Okay, so that means you need a subscription, active subscription on your VM from SUSE. But since we have created an image from. We have created this VM from an image of BYOS. Bring your own subscription. So that means we don't have a subscription, active subscription on this node. So we won't be able to update the node. So that is the reason I am just I'm just marking it as not applicable. In your case, you can run this zipper update. It will update the system packages of the VMs. Second, this configuration has to be no. So by default, it is yes. By default, you can see this cloud net config manage is equal to yes. So just disable it. Now you can see it has become no. On both the nodes, I change it. Now set up passwordless SSH. So you have to configure passwordless SSH from one node to the other node, from node 1 to node 2, and from node to node 1. So first thing, we have to create a keygen. You have to create a keygen. generate RSA key on both the nodes. You have to generate RSA key on both the nodes. So this is node 1 and this is node 2. So we have created the RSA key on both the nodes. After creating the RSA keys, then we have to copy the ID, copy the private key, copy the private key, copy the public key from node 1 to node 2. So here I'm copying the public key from node 1 to node 2. Yes, it is asking the root password. Okay, here you can see number of keys added is equal to 1. So the key has been added to the other system. And it is saying if you want to check it, you can run this command. So I will run this command SSH and node 2. So if I run this SSH node 2, you can see that I have been logged into the node 2 without asking for any password. So now I have configured password as SSH from node 1 to node 2. Now again log out from the node 2, you will again fall back to node 1. So node 1 to node 2 is done. Now you have to configure passwordless SSH from node 2 to node 1. So similarly, you have to copy the public key from the node 2 to node 1. Okay, the key has been copied. It is saying you to run SSH and verify. So I'm running SSH from the second node to the first node. So here you can see I've been logged into the first node without asking for any password. So this is passwordless SSH. So I have configured passwordless SSH. Okay, I have configured password SSH. Now I have to configure setup cluster on node 1. I have to configure cluster on node 1. HA cluster init -u. This is a command. You have to run it on node 1. Just make sure, don't make any mistake. Don't run it on node 2. So here, click it on node 1. HA cluster bootstrap is deprecated. Please run CRM cluster unit -u. Okay, let me click on it. Let me see, let me run this. Okay, so here, do you want to continue? Yes. Okay, address for ring 0. Address for ring 0, 10.2.15, 10.2.15. So just press on enter. Just press on enter. Port for ring 0, 5405. Just press on enter. Then do you wish to use SBD? Do you wish to use SBD? Yes. Yes, enter. SBD is already configured to use this disk ID. SBD is already configured to use this. Override, yes or no? So don't override, just click on no. Enter. Waiting for cluster. Do you wish to configure a virtual IP address? No. No. Enter. Do you want to configure a queue device? No. Enter. Okay, so I have configured the first node. The configuration on the first node is done. Okay. First node has been configured. Now, second, I have to run the join command. Now you have to run the cluster join command on the second node. On the second node, you have to run the cluster join command. Again, it is the command has been deprecated. Now this command. Control C. With this command, CRM cluster join. IP address or host name of existing node. So here you have to give the IP address of the first node. You have to give the IP address of the first node, 10.2.1.5. Okay. Do you want to continue? Yes. Address for ring 0. So address for ring 0 will be the default. Just click on enter. Okay, so the configuration is completed on the second node. Next point is to change the password of the HA cluster user. If you see here in this configuration, it says login with username HA cluster, password Linux. So the default password for the HA cluster user is Linux. And since it is a known password, this is a known standard password, common password. So it's recommended to change this password right after you configure the cluster. So change the password. I'm changing the password to my master password of my database. So on the node 1, I'm changing the password. This is password updated successfully. Also on the node 2, I am updating the password, changing the password. Done. Password change on both the nodes. Okay, actually this involves a lot of configuration. Okay, this involves a lot of configuration. So okay, adjust corosing settings. So this is, you have to adjust corosing settings. You have to just change some token values and consensus values over here. So first take a backup of the configuration file, change the value and see the difference. So both the nodes, you have to do it on both the nodes. Okay, so you can see these are the changes. That the previous one was 5,000, we have changed it to 30,000. And then this consensus, it was previous 6,000, which we have changed to 36,000. So these are the two changes that we have done in this file, etc corosing.conf. Okay, after that, just restart the corosing, service. If you have only changed it on the first node, you have to do it on the second node also. Okay, I've done that on the second node also. Now restart this service. It has started on the first node. Let me start it on the second node also. Okay. You can see it has added the second node in its configuration. Earlier, there was only one member in the cluster. Now it has added to, so there was only one node. The first node was only added into it. Now it has added the node 2, and now there are two nodes in this cluster, 1 and 2. Okay, so I have adjust corosing settings, restart corosing service, check pacemaker service, check if the pacemaker service is running or not. So this is the command to check the pacemaker service. So you can see the pacemaker service is active and running. This is actually the cluster service. This is actually our cluster service. So check it on both the nodes. So I can see that on both the nodes, the cluster service is running, active. Now check cluster configuration. Now with this, you can check the configuration. These first three commands you can run on both the system because it will give a slightly different output. So this first command, corosing cfg -s. So you can see a little, just slightly different. It will just give the change in the IP address. Here it is 5, here it will be 6. Just a little change. Then corosing quorum tool. Okay, if you see the output, both the output are almost identical. Only difference is that here it will be local for this 5 IP, and on the second node it will be local for the 6th IP. Porosync CPG2. I think this is almost same. No changes in the third one. There is no change in the third one, so no need for running it on both the nodes. You can run it on any node. Any node. CRM configure show. It will show you the configuration of the cluster. No need to run it on both the node. Just one node is enough. So this is now the existing configuration of the existing cluster. Cluster status. This is the status. You can see active running. So Porosync active running, pacemaker active running enabled. Now the CRM status. Now check for the cluster status. So this is our CRM status. So what you should see over here, there should be 2 nodes with status online and the message partition with quorum. There should be 2 nodes with the status online. There should be 2 nodes with the status online. And with partition with quorum. Okay, so if you come over here, if you see, so there are 2 nodes. If you see the number of nodes, there are 2 nodes online, 2 nodes, HTTP PID1, PID2, node 1, node 2, 2 nodes. There should be 2 nodes with status online. So this is the status online for 2 nodes. And the message partition with quorum. So here you can see partition with quorum. So this is the 2 things that you should observe in this command over here. This is the initial one. Now we will start configuring the cluster. Now let us start configuring the cluster. Better if I just leave it down. Okay. Now you can also see a graphical view from a browser, which is also called as a cluster web console. If you want to monitor your resources from cluster web console, you can need to first start the service, Hawk service. You have to start it on both the nodes. Okay. Once it is started, then you can access this service from here. I think it's better if you install the Chrome. Any doubts and queries as of now?
We cannot remember all these things, no? We have
So
to
that is the reason I have documented it, na?
No. I suppose if we have to give service or if we have to give interview or whatever, these are all the things which are
Okay, so now if
heavily
you
based on network.
to answer your question, see, actually what I've been teaching over here, it's a mix and match of many responsibilities. Okay.
Okay.
Here in this scene, you have also created the load balancer, you have created the disk, assigned it to your disk, you are also configuring the cluster. So in real-time scenario, you might have different team or different people for doing different jobs. Okay, for in case of creating the VM and creating the load balancer and creating everything, you might have a cloud consultant for doing this job, Azure consultant, and for creating this cluster. For the creating the cluster, it will be done by the Linux administrator or the system administrator, the OS team, system team. Okay, your part will come much later. But if you see to get a better understanding of the actual functioning, So if you understand each and every roles and responsibilities, that it will become a very clear picture to you.
Yeah, absolutely. Absolutely.
So here it is. Now you can open this link here in this Chrome. Privacy. Advanced. Proceed. Advanced. Proceed. So this is the web console. Okay, this is a web console for the cluster monitoring. You can configure it also from here, but this is not as strong as a command line. And the user that you can log in with the HA cluster user. HA cluster, the password for which we have changed to India123. Okay, so yeah, right now only the Stonit device has been added in the list of the resources. Here also. So let me just minimize it and move forward. Start. See, whatever I've been teaching up till now, it is not easy to remember everything in one go. You can understand, you cannot grasp everything in one sitting. Okay, that is the reason we have been recording. We have this recording. So the next time you have to go through this recording at least 2 or 3 times. So the more and more it will like come again, come in front of you. It will again go through the recording. Many of the concepts will slowly get clarified in your mind. Okay, now it has completed. Now till now we have completed up till now. Now the second part is for implementing the Python system replication hook. Hook means it's a small program. It's a small application. What it does, cluster uses this SR hook, SAP HANA system replication hook to monitor the replicated services and the database and the services. And with this, it can identify whether the database health is healthy or not. So before implementing the Python hook, you need to stop database on both the nodes. Log in with the SID user and stop the database. Okay, the database is stopped on both the nodes. Come out of it, log out from the user SID user. Okay, so now integrate the hook in global.ini on both the nodes. So this is the hook. Actually, this is nothing. Just it's a part to the hook. This is the path to that hook. USR share SAP HANA SR. This is actually a script. This is actually a program in Python language. So you are just adding this path in your global.ini file. So what you need to do first, take a backup of the global.ini file. This is the location. Then HANA shared SID global HDB custom configuration global.ini. Take a backup of this file on both the nodes, and then you have to add this in both the nodes. Okay, add this settings or add these parameters in the global.ini on both the file, and you can check the difference. So here you can see this is new in the new file. Okay, so I have integrated the hook. Okay, now set start database on both of these. After adding the parameter configuration, now just start the database on both the nodes. And start the database. Node 1, let us start on the node 2 also. Check the status, the replication status on both the nodes, HDB and SLittle. Okay, so this is in the sync state. Delhi is in the sync or secondary state, and the primary this is the primary node. Okay, this is the primary. This Mumbai is in the primary state. Okay, so both of them are the proper. So I've started. If you want to check, verify the hook integration on the primary. So run this command on the primary node, and you will see. You can run it from either SID ATM or anywhere. So you can see the hook has been integrated with your database. Calling CRM sudo Delhi sfail sfail. The hook has been identified. Now we will start with the configuration part. Now we need to start with the configuration part. Do you want me to take a break of 5-10 minutes before starting with the configuration? Yes, everyone. Do you want me to take a break of 5-10 minutes?
Yes.
Okay, so let's take a 10-minute break and we'll meet again at 9:25. Okay, so here we have started the topology for the HANA. So this is the HANA topology. It has stopped right now. Now configure clone. You have to create a clone for this topology. Okay, so we are going to create a clone for this topology. Okay, this is also done. Now primitive for the resource. This is for the HANA resource. So here, if you see in the last line, you can see the automate underscore register is equal to false. So this is the default. If you want, you can make it as automate register is equal to true. So next time when the system reboots, next time when there's a failover and the primary node, when it comes back, then it will automatically register to the cluster. Here we have created it, and here we can see it. CRM configure this initially true. Clone set. This is also done. CRM configure primitive. This is for the cluster. Sorry, this is for the virtual IP. This resource is for the virtual IP. Okay, the virtual IP will be 10.2.1.11. Here I am creating for the virtual IP. Okay, so you can see the virtual IP has come up over here. This is the virtual IP resource. And we'll create another resource for the load balancer. This resource is for the load balancer. This resource is for the load balancer. So this is for the IP address. This is for the load balancer. Better make it as LB only.
Muzaffar, can you just point right down this point? This is for load balancer. That's it.
Here it is here, na? Create a virtual IP resource and group, create the HANA resource.
Oh, no. This one is for load balancer. See, the one which you have just done.
I can't get you. What you said?
This one, CRM configure primitive resource. This
Okay.
one. This one, yeah. This
Here
is
you
for
can see
load
Azure minus LB.
LB. Okay.
This is for load balancer. Okay. CRM resource status. CRM resource status. So this is for the load balancer. So let me rename it CRM resource. Rename this to such command CRM. CRM configure rename. Okay. CRM resource status. So now it has been renamed. This is the IP resource. This is the IP and this is the load balancer resource. If you check it from here, this is the IP and this is the load balancer resource. Okay. Now we have created this resource. Now put both of these resources in a group. I am putting both of this resource in a group. So it is easier to identify and move the service from one node to another. So now if you see these two resources are on independent or both are independent. Now I'm putting them into one group. So CRM configure group grp underscore IP and we'll put these both of these. So here, if you see, this is a it has created a group resource group grp underscore IP, and both of these resources have become a part of that group. So now you configure the resource. Now configure resource constraints. Okay, there are some constraints or limitation. If this resource moves from one node to another, then how should the behavior be? So these are related to that. So everything is done. Now the last thing is that if you see over here, you can see that some of the resources have failed resource actions. So this normally happens during configuration. The only thing is that you need to clean it up. Once you clean the resource, everything will be rectified and cleared. So I'm clearing resource. Okay, now if you see, it will again run a okay. Before starting this, let me just run one check whether everything is okay or not. SU minus H4P. Let me check the database. Database is running. Okay, database is running. Let me check the status of replication status. Okay, this is the sync node, secondary node. Okay, let me check for the first one. SU minus H4P ADN. The database is running. What is the state of the database? Okay, this is a primary database. Okay, now everything is okay. Now let me just bring the resource, bring the cluster out of maintenance mode. Once I bring the cluster out of maintenance mode, it will start monitoring all the resource and try to bring all the resources up. So here I'm running the command for bringing the cluster out of maintenance mode. Now you can see there is a lot of movement in the cluster. So it is starting, you can see it is starting all these resources. Started. And you can see that HDB PRD2, the second node is actually in the save slave status. First one is in the master. First one will become the master now. Okay, so now you can see started the PRD1, PRD2, both the nodes. The topology service on both the nodes has started. Started HANA PRD01, PRD02. The topology service on both the nodes has started. Now the second node has been identified as the slave node. Now it will check for the first node. It is monitoring it. Let me check if everything is okay again. To primary. Let me again do the cleanup. Let me again run the cleanup. Okay, now it is showing a stop. PRD1 is showing a stop. It will, I think it will take some time to monitor it. So it has started promoting. It has started promoting the PRD01. You can also monitor it from here also. Now you can see there are many services or have come up over here. Okay, it has become a master PRD01. Okay, it is complete now. So you can see the topology service has started on both the nodes PRD01, PRD02. The HANA service, it is the master. PRD01 is master and PRD02 is slave. So this is the primary node and this is the secondary node. This is the IP. Okay, the IP has started and it is also showing the load balancer. If you want to confirm the IP, right click. Let me ping the IP addresses, ping 10.2.1.5. This is the node 1. It is running. Now let me check the node 2. This is also running. Now let me run the node 11. So can you see the virtual IP is also started pinging now. The virtual IP has also started pinging now. Okay. So here it is everything is configured up and working. If you want, you can also add the system in HANA Studio using the virtual host name. Okay, so how was today's session? Any queries?
We'll be able to do this practical also, correct?
Yes, if you want, you can do it. No issues.
Okay.
Okay, so it has gone down. This dev servers, this is not running actually dev servers. That is the reason. Let me log it off. Dev server. Here also dev server. Log off. Okay, then comes the PRD2. The PRD2 is now in the secondary mode. That's why it is showing as a error. PRD2. So this is the PRD1. This is the PRD1 running. If you want to add, you can add the system now using the virtual host name. So the virtual host name is HDB PRD. This is the virtual host name, HDB PRD. Okay, instance number 01, HDB PRD is a multiple container system database, and this is the active node, the PRD node, not the PRD1 or PRD2. Makes this as by system. Okay, can you see it has been added? I've added using the virtual host name. I've added the system using the virtual host name. HDB PRD 01 multiple containers H4P PRD. Next, okay, see both of the nodes have been added using the virtual host name. So it is accessing using the virtual host name. It is actually showing you the status of the PRD01. Now, if the cluster moves in the background, it will show you the status of PRD02. So it is showing you all the details of this. And now let us do some cluster failover testing. So we have configured the cluster, but what is the use of a cluster if it doesn't works as expected? So okay, now test the cluster. So you can use these two commands to check, monitor the cluster. Monitor command. Here, run this command. So here you can see overall status H4P is in green. Sure. Cluster green status, HANA 1 green, HANA 2 green. This is for the Python replication hook, Python replication, HANA replication hook. This is green. Everything is in green. Everything is in green. Second, show attribute. You can run this command to check the attribute. So here you can see this is the first node, PRD01. This has been promoted. This has been promoted to the primary host, and this is the role status is online. It is running in the log replay mode. This is remote host is PRD02. Okay, this is the site name Mumbai, and the sync status. This is the sync status is primary. Premier means primary. This is for the secondary node. The status is demoted. Okay, online this is the Delhi side. It is in the sync mode, and the status is SOK. SOK means sync okay. The synchronous status between both the nodes is okay. Okay, if this node, this has to be SOK. Otherwise, when you do a failover, it will fail. If this sync state is not SOK, then the takeover will fail. This is how you can do it. Now let us do some failover testing. How can we test our cluster testing? Procedure 6.1 test procedure CRM. Run the cluster, monitor the cluster. So we are already monitoring the cluster. This is how we are monitoring the cluster CRMA. You can also monitor using this command, watch. So let me run this command also to monitor the cluster from root user. Okay, here we are monitoring the cluster. This is also we are monitoring. Now what we are doing, stop the primary HANA database gracefully as SID ADM. HDB stop. Here, this we are running from the primary node. SU minus H4P ADM, and here we are stopping the database. See, once you stop the database, just see the movement in the cluster. After some time, as soon as it recognizes, it is as soon as it monitors and finds that one of the database primary has gone down, it will start making some changes over here. Still, it is not down. It is still the database is going down. Okay, can you see? The master has failed. The master server has failed. Now the IP address has started on the secondary node. The IP has started on the secondary node. So how we can identify? If I go on this first node, if you run this command IPA, if you run this command, this is my ETH0, and you can see my IP address over here. This is my IP address 10.2.1.5. If I come on my secondary node, here if I run the IPA command, you will see the virtual IP. Can you see the virtual IP? Here is the virtual IP on the secondary node. Earlier, this virtual IP was there on the primary node. This is my physical IP address. This is my physical IP address, and this is the virtual IP address. This is assigned to my physical IP address. Here it is not here. Earlier it was there. Next time when we change from the secondary to primary, you can observe that. Okay, here we have seen, okay, that it is promoting the PRD2 now. It is promoting the PRD2. Means it is making the PRD2 as primary, or you can say it is running the takeover command. The secondary HDB PRD2 system is not taking over. Node 2, node 1 has stopped.
During this time, application will disconnect.
The application will go in a hang state. It will not respond for that time.
Okay.
And only the running transaction, if you are running or saving some transaction, only that transaction will be lost.
Loss means the whatever is already done, it will
for
not
example,
be
the
captured.
current, for example, if you are creating a PO, okay, you are creating a PO, you put the name of the customer and the date, and
and you have
and you
not committed.
It's not saved yet. It's only that screen or that PO will be lost. So that you need to again recreate it again.
No, who will tell that this has happened? Because customer, the front-end user will not be able to know
but
that.
see, till the time there on the screen nothing. But as soon as they click on save, as you click on save, the information is taken to the backend system and is saved there, and the acknowledgement is given to the front-end SAP GUI that this record or this PO has been saved. If there is some changes in the backend system, you will not get an acknowledgement this PO has been saved. You will get an error message, disconnection message, error message.
Just like session is killed like this.
Yes. Actually, this is the same working scenario of all the types of applications. If the backend goes down, the front end will not give you a confirmation that this record has been saved. So that means you have to again go there, cross verify, and create it again. Is it clear?
Yes. That is what
okay.
I wanted.
Now, if you see over here, the master server is now the PRD02. PRD02 is now the master server. The PRD01 has been stopped. Okay, we have stopped the system. It has been stopped. And here, if you see over here, SU minus H4P. Here, if you see the HDP-NS util, if you check the state over here, the secondary system has become the primary, or Delhi side has become the primary. And here, if you see the monitoring, if you see earlier, you can see the S fail. S fail means synchronization fail. So the first node has failed. The first node has failed. The second one has been promoted, and the second node has been made the primary system. Okay, and if you see from here, you can see this chain. So this is the automated failover. The cluster identified the issue and just failed over the resource from the primary or the node 1 to the node 2. Expected. The cluster detects the stop primary HANA database on node 1 and marks the resource failed. Okay, so here if you see the resource, it will say it's showed as failed. No, here it is only showed as okay, here it is failed. So here on the node 1, it says PRD node 1 has failed. It will say tell the resource marks the resource as failed. The cluster promotes the secondary HANA database on node 2 to take over as primary. The cluster migrates the IP address to the new primary on node 2. The cluster migrates the IP address to the new primary on node 2. After some time, the cluster shows the sync state of the stop binary on S1 to S fail. So here is the sync state. Here it is showing as S fail. Recovery, how to recover it. Now that was your test process. That was the test scenario. What you did, you stopped the database. Now how to recover it? Manually register the old primary on node 1 with the new primary on node 2. So previously the node 1 was primary. So now what you need to do, now the node 2 has become primary. So now you have to register the node 1 with the node 2 as a secondary system. So HDPNS util this you have to run this command to register the secondary. Now the first one, that this server will become the secondary. SU minus H4P ADM. Now if you see the HDBNS util, so here it is still showing as primary. It is still showing as primary. Now what you need to do, you need to register this server as secondary. How will you do that? You have to run the command. You have to register this server as secondary. Okay, the first one, I have to register the first node as secondary. So here it is. So this is the command to register the first node as secondary. Okay, I will register the first node as secondary, then again run the HR state and then start the database. So now I am running this command. Okay, I've registered the system. And now if I run the HDBNS util SR command, now it will show me as a secondary system. Can you see the mode has changed? Previously the mode was primary. From the primary, now the mode has changed to secondary. From the primary, the mode has changed to sync. From primary, it has changed to sync. But still it is not recovered yet. If you see, it is still showing as S fail. Okay, and it is here it is still showing as stopped. So now what you need to do, you have to start the database on the first node. You have made it a secondary, you have registered as secondary, now start the database on it. Once you start the database, you will see some changes. Here this will again become SOK. SOK means sync OK. From S fail, sync fail to, it will become SOK. You can also run this command on primary. Okay, you can see it is initializing. Okay, preparing persistence. Okay, this is also active now. This is syncing, preparing persistence. Okay, all have become active. Now, if you check over here, it is still showing as SL. Maybe after some time, it will show the status as SOK. And here, okay, here before it changes this status, I need to clear this error. Once I have rectified it, I need to clear this error. If you see expected, because automated register false, the cluster does not start the failed HANA database or register it against the new primary. Restart the database now secondary on node 1. Watch this. See, now you have to clean this resource. Clean this resource. Clean this resource from here. This command. CRM resource cleaner. So I've run this command on this node with the root user, and you will see the changes over here. You see it has started refreshing. Now it is showing that the one as stopped. It is showing one as stopped. Now it will show it as slave. Okay, slave HDPRD1. Okay, can you see now the node 1 has become the slave and the node 2 has become master. Okay, can you see the topology now has changed to SOK. It has been demoted. The first node, the primary, earlier primary has been demoted. Now it is in sync status and the sync is okay. Expected after the manual register, the resource cleaner, the system replication pair is marked as in sync as okay. The cluster failed actions are cleaned up after following the recovery procedure. Okay, is it clear?
This note you will share with us, correct?
Yes, yes. Then. Okay, so this is a whole scenario by which you can test your cluster. There's a lot of scenario. You can run the HDB stop on any of the node, and you can then again you can stop. First you stop the primary database on node one. Second scenario, stop the primary database on node two. Third scenario, crash the primary database on node one. Then crash the primary database on node two. So let us check this. Crash the primary database on node two. So how you can crash it? HTTP kill -9. You can run HDB kill -9. It will crash the database on the primary database on node 2. So node 2 is my primary right now. Node 2 is my primary right now. So I will crash my database over here. Let me start the crm underscore mon minus rm. I'm run this command over here. Watch essentials. I'm running this on the primary file. And on the secondary, I will crash the database. Okay, I'm going to crash the database. This is the secondary node, come out of it. So now SU minus H for the ADM. Okay, the database is running in this. The database is running and the state of this database is primary. The database is primary. Okay, now I'm going to crash this database. HDB kill -9. The database has crashed. Now you can see the changes. After some time, you'll see the movement in this cluster. Because cluster doesn't senses the service down immediately, because there is an interval between the monitoring task. So there is maybe some interval of 10 or 15 seconds. So when it runs the monitoring task and it finds that the database is not running, it will take the corrective action. We'll kill the database. Okay, can you see it has now monitored, it has now find that the database is down. It has started, you can see the slave is PRD01 and the PRD02 has failed. Node 2 now it has started promoting the node 1. It has started promoting the node 1. Promoting the node 1 as primary. You can see some changes here also. Still here there is no changes over here. It is still promoting, it is still bringing up the database PRD01. If you want, you can run this. So this is the secondary side. Okay, so it has become the master. PRD01 has become the master. Secondary, it is no secondary site is attached. You have to manually attach the secondary. You have to manually register the secondary. Okay, this has become fail as fail. Now the node 1 has become primary. It has been promoted and it has become primary. Okay, here you can see the masters. Node 1 is master and second node is stopped. So now we have to do the corrective actions on the second node. Why it crashed? What was the reason for it? Correct it, and then you need to bring it up and then re-register it as a secondary node. Re-register node 2 as secondary. Now we have to again. It has crashed. Here you can HDB is already stopped. Database is already stopped. Now what you do, you can just register it as secondary. Or not a register, you can register it as secondary. This is for registering it as secondary. What is the current SR state? Current HR state is primary. You have to register it as secondary. Okay, register. Now if you again check the SR state, replication state, now it has become sync. It has become sync and now start the database and it will be added to the cluster. Okay, it will. Okay, you also have to clean this error message. You have to clean this error message. And the HA, you need to run resource cleanup. Run this resource cleanup. And you can see it has been cleaning up this resource. Okay, now it is the slave. Primary HDB02 has now become the slave. Okay. It will again get demoted. Now it will change to SOK. After some time, it will change to SOK. Okay, this is the ideal condition. One of the nodes should be master and the other node should be slave. Then only there will be a failover. Is everyone clear with it? Any queries? Any doubts? And these are all the links for which you can, if you want, you can do some more reading to understand details of this cluster configuration. Okay, so all links from Microsoft, Red Hat, Google, Cloud.Google, and even SAP.com, blogs from SAP. Yes, any doubts, any queries?
So if suppose we have to shut down the primary database, suppose 01 for some time due to some reason for upgrading, suppose memory or something. In that case, do we have to stop this HA because we know it's not crash? It's a maintenance activity. So how we can stop the automated HA?
Okay, you can, the first thing is that you can put the cluster into maintenance mode. Once the cluster is in maintenance mode, it will not take any action.
Okay.
Was that your question?
Yes.
Okay, so you put the cluster, and second thing, for example, your node 1 is primary. You want to do some corrective actions on node 1. Okay, then you can manually fail over the cluster to node 2. Okay, so sorry, actually, there is all these commands are here only. You can check it from here. Okay, test procedure, stop primary database, stop primary database. No, not in this system. Cluster migrate. Okay, here it is. Migrating a HANA primary with unmanaged master slave resource. CRM resource unmanaged. This is a lengthy procedure. You can just ignore this one, can go with it. Migrating a HANA primary using cluster migration command. Just run this command. Cluster CRM resource move. This resource forcefully. It will move, and then you can again register the first one as a secondary. Okay, by running this command on the primary, it will move the cluster to the secondary node. Secondary will become primary, and with this command, you can register the for node 1 as a secondary to the primary node, and then you can just clear the resource there. You just have to run this CRM resource clear. In case of any failure, something like it, show you what is it.
This is only one command through which we can do it manually, correct?
Yes, there's
it
two
is only
commands
when
actually.
it is only when the HA is configured.
Yes, only when the HA is configured. Also, in the second option, you can also restart the first node. As soon as you restart the first node, the second node will take over. The second node will become the primary. Okay, then you can manually move the resource for this command. You can also put the first node in maintenance mode. Sorry, standby mode. You can put the first node in standby mode, and all the resources from node will be migrated to the second node, and the first node will become a standby node. It means that no services should start on the first node because it is in standby mode. So during the time it is standby node, you can do all your corrective actions on the node 1, and after it is completed, you can bring it online with this command. You get it? So now let me move my cluster to the secondary node. So how will I move? So right now, the prime master is PRD01 and this is PRD0, slave is 02. So I'm running a command on this node, second node, CRM resource move. CRM resource move. Okay, running this command CRM resource move. Which resource I want to move? HDB01. This is a resource. This is a resource. Resource SAP HANA SID HDB01 force using the option force. I run this command, and you can as soon as you run this command, you will see the updates in your cluster, movement in your cluster. I have run this command. So now you can see there is some movement in the cluster. It is started. You can see it has started stopping the PRD01. It will stop the PRD01. It will promote the PRD02 as a primary node. So right now it is stopping there on the primary node HDB01. Okay, now it is promoting the secondary node. It is promoting the secondary node as a primary. The primary node has stopped. The services on the primary node has stopped, and it is promoting the secondary node as primary. And after it is done, you can register the secondary node as a And don't forget this activity. If you don't register the node 1 as secondary, next time the failover, if the second node goes down, if the failover will not happen, because the primary because the node 1 is not in sync. Do you get what I'm saying? If the cluster has failed over from node 1 to node 2, but you have not registered the node 1 as a secondary node, you have not registered the node 1, then your secondary node, your node 2 is working as primary. It means whatever changes have been made on the primary had not been replicated on the node 1. So in case the second node, the node 2 goes down, there will be no failover because the node 1 is not in a position to take a failover from the node 2.
Yes.
Since you have not registered it as a secondary. Okay, now can you see over here? The node 2 has become master and the services on the node 1 has stopped. So now what you have to do, you have to start this service. You have to register your secondary node. You have to register your secondary node. Register. SU minus SR state. So it is actually in the primary, it is the mode is primary. So let me register it as secondary, check the SR state. I have registered it as secondary. Checking the SR state, now it has become sync. Let me see if it senses that it has the register and it makes any changes or not. Okay, now next step we have to do, we have to resource CRM resource clear. As soon as you clear it, now you can see that it has started. It has started starting the node 1. It will start the node 1 as secondary slave. Okay, so now you can see that the node 2 has become the master and the node 1 has become slave. Yes, is it clear? Any questions, any doubts? So now let me shut down the service. Now since node 2 is primary, node is primary. If you want, you can shut down the node 1 first and then you can shut down the node 2. If you want to keep the setting as it is. If you want to keep the node 2 as primary only, then first shut down the node 1. But if you want to make node 1 primary, then shut down the node 2. As soon as you power up the node, the cluster will start failovering the service from the node 2 to node 1. If you see over here, the cluster has started failovering the service. It has started demoting, stopping PRD02. And this has become primary. Okay. Nodes 2 has stopped. If you see over here, node 2 has become offline. Only node 1 is online now because we have shut down the node 2. So node 2 has gone down offline and node 2 has stopped. Here also you can see node 2 has stopped. Here also node 2 has stopped. So this is it. And if you want to see the live IP now, see the live IP has now come on PRD01. If you want to see the live IP, you can run IPA. So now you can see the live IP over here on node 1. Okay. Forwarding the output. Yes, any doubts and queries? Yeah, can we close today's session? No queries, no doubts. Okay. Yeah, goodbye everyone. See you in the next class
Okay.
tomorrow.
Okay. Good night.
Good night.